doing every challenge question. It's the review exercise 3. It's going to be the last one from book 1, which is fantastic. Position vector is this, apparently. Position vectors, of course, start at 0, where theta is between 0 and 90 in this case. Find the value of theta when it's bearing 90 degrees forward origin. So remember, bearing goes from upwards clockwise. So 90 degrees is going to be straight across, which means that I don't know what this magnitude of the I vector is, but I do know that the j vector is 0 because it's going straight across. So therefore, sine of theta equals 0, which happens when theta is 0 in this range here, of course, because sine starts at 0. Calculate the magnitude. The magnitude of a vector, if the vector is ai plus bj, is this, where a is the thing here and b is the thing here. But of course, cos squared plus sine squared is going to be 1, and root 1 is just 1. So the magnitude is 1. Good. Cubic function has turning points here and here. Now what that means is the gradient of the function is 0 at x equals minus 3 and x equals 2. And what we can do is we can just apply factor theorem here to f dashed of x, because it's just some function, right? So therefore f dashed of x equals x plus 3 into x minus 2. And if those are the only factors, then that's all we can put there, times by k. Of course, we know f dash of x is a quadratic because the original thing is a cubic. The reason there's a k here is because, of course, I don't know what the scale factor on any of this is, because k wouldn't, it wouldn't affect the fact that it has roots here and here. So I need to put a k there. And of course, there's a k here, so that's why I've chosen that letter. Good. So that's that. And all we have to do here is we can just integrate both sides, right, to find f of x. Well, I could expand it out to show this first. But yeah, integrate both sides. Of course, just integrate the inside of this to get this. Don't forget the plus c. And now we can just, because we have f of x now, we can just put in these two pieces of information. When x is minus 3, f of x is 76, and this one as well. Do a bunch of maths and sort it all out. You get this. Same thing for this one. Do a bunch of maths, sort it all out, get this. And now if we do this one here minus this one, we'll get rid of the c's. So let's do that. The 1, 2, 5's cancel, and you get k as 6. You can shove k as 6 into all of this. You can also put k of 6 into here to find c, and you'll get c as minus 5, of course, because 6 times 3, or 6 divided by 3 is 2, that makes minus 44, and it's there to get minus 5. Anyway, now put k as 6 in here, and c is minus 5 in here, and you end up with this thing here. K as 6 is nice, right, because it just cancels down all those fractions, and you end up with this, which is good. Number 3, so we have some integral of some function as area, as answer this between 0 and 9. Now what that means is that the area between 0 and 9 is that number there, for whatever function this is. Now, if you do this, this is moving the function up by 3 units, the entire function. So it looks a bit like this now, where if you put this as 3 here, you've just lifted the function up those 3 units. And of course, you've created all of this extra area, which has size 9 times 3 for 27. And so now the integral of this function here is just 24.2 plus this extra 27 you invented, which is 51.2. And the last one here, this line shouldn't have turned up straight away, but I can't be bothered to fix that. F of x is this, g of x is this. This is a really weird question. F of 0 is clearly 1. G of 0 is e to the power 0, which is also 1. So they intersect at points 0, 1. So if you draw a graph, they intersect at 0, 1. And now this is just some exponential function, right? So it looks like this. And the red line is the tangent to the function at the point they intersect. Because what b is talking about is the tangent to the exponential and the tangent to the cubic are perpendicular. So the cubic is gonna do something to make a tangent line, which is kind of in this direction here. But I actually don't need to draw the rest of that, because halfway through the picture I realized that the picture was pretty pointless. All I really need to do is differentiate g to get this, because the 2 just moves down. Plug in x is 0 to get 2. And so the gradient of its tangent is 2. If the gradient of the other tangent is perpendicular, that means the gradient of the other tangent is minus a half, which means the gradient of f is minus a half, because the gradient of its tangent is equal to its own gradient. That's the whole point. Is gradient spelled with an A? I can't remember, I'm tired. Anyway, so now we say clearly that therefore f dashed of x equals minus a half at x is 0, but f dashed of x is 3x squared minus k, so you say, well, that equals minus a half at x equals 0. So x equals 0 just makes this minus k, which means k is just equal to a half. And I think we're done.